Okay, dear student, we are conducting the mock interview of our student Ayush, and this interview for IISC. And now, let's start. Ayush, please introduce
Yes.
yourself.
Sir, my name is Ayushman, and I am actually a resident of Bihar. I have done my B.Tech from University of Calcutta. I have got the 8.67 CGPA in Electronics and Communication Engineering. In that, I have in final year projects, I have done a good project. Actually, I have awarded second in my college life, and the project name was that using prediction of diseases, plantar pressure prediction of diseases using machine learning tools and hardware implementation, sir. In that project, actually, I have made a machine learning algorithm by which we can predict the diseases that caused by the plantar pressure, means the pressure created by the foot area. Mainly that disease is actually diabetes. And I have also done a mini project, which is on the based of the Hartley and Colpit oscillator and stimulated on the LTS spice for that thing. And today I'm here after I have also created the gate of a score 596 in ECE domain actually.
Okay, what is your rank? What is your rank?
Sir, my rank is 1112 actually, and currently I am working in a core company, electrical core company, which is in the Delhi. Yes, sir.
Okay. So, which subject are you preparing?
Sir, I am preparing for a electronic product design. Means my interview is for electronic product design and semiconductor in IISC.
Okay. Okay. Now, let's start very basic question from the semiconductor. Explain the Fermi energy level with respect to how it created the donor energy level, how it related to the N-type, P-type. Explain all the things.
Okay, sir. Actually, first, the energy level is the highest energy of the electron or highest energy of the particle in the semiconductor, and it is actually for a interesting semiconductor as well as for the extrinsic semiconductor. For me, energy level is the highest energy level actually. If you ask me for making the graphs and the energy band diagram, then I can also show you that how the donor energy level and valence acceptor energy level is being created also. Can I share a screen if you allow me to draw and all?
Okay. You can make a diagram on paper. Do you have pen paper?
Yes, sir. Yes. I have pen.
Okay. Simple. Draw on your paper and show me.
Okay, sir. Okay, sir. Actually, sir, we actually used to find the energy band diagram in the crystal structure, because if we will take a particle, if we take a single atom, then we can't find the energy band diagram. We can only find the energy band diagram in the crystal, where we find that when the crystal is actually there, then in the interatomic spaces they actually combines, and in that, according to the Pauling also, that there are different energy states where the electron resides. So in that condition only we used to see the energy band diagram. Actually, energy band diagram is actually we actually discussing about semiconductor like silicon, germanium. So in that, these band diagram is being created. For the band diagram, it has actually energy levels, energy states. First energy states, upper energy states is the conduction band, that is denoted by EC, while the lower energy state is given by EV. EV, actually the most of the electron that resides in, actually it resides in the EV, means valence band actually. And between the EC and EV, there is energy gap. In that, we will not find any type of electron staying there. Okay, so sir, as we are talking about intrinsic semiconductor, so electrons which is on the lowest energy state, because electrons always wants to be in the lowest energy state, so it always resides in EV. Like this, as you can see, this is EA and EV. It might not be seen
Clear.
due to mirror imaging. Okay, sir. So actually, this is created. So when we increase first condition for the electrons to move from valence band to the conduction band. First, I am let me explain the conduction band. Conduction band is a band where the electrons becomes very free.
You are explaining too much. You are explaining too much. My question
Sir,
was
yes, you said all things.
simply
That's right.
explain the Fermi energy level with respect to n type and p type.
Okay,
इसमें
sir.
पूरा कंडक्शन बैंड कहाँ आ गया? कंडक्शन बैंड समझाने की जरूरत क्या थी? आपने
आपने
बहुत
सर
ज्यादा
बोला
समझाते हैं और मैं इसमें लास्ट
okay.
वीडियो में तो कंक्लूड करूं. चले, लेट्स
Okay, sir.
move to
So
another
for the
question.
P,
Let's
okay,
move
sir.
to the another question. Let's move.
Okay.
What is the charge on the semiconductor? N-type semiconductor.
Sir, there is no charge in the semiconductor. Means
Why?
it is neutral. It is actually neutral because externally there is no charge. Actually, P-type semiconductor is just made because of the vacancy of the spaces. Because in the P-type semiconductor, we used to add the
What was
you
my
asked,
question? What was my question?
sir, is is there any charge in that in semiconductor? So there is no any charge.
What is the charge on the N-type semiconductor? You explain the P-type semiconductor.
So
As
okay.
Both are neutral, that is okay. But
Yes, sir, both are neutral.
Both are neutral, that is okay. है ना?
Yes,
But यहाँ आपको क्या लग रहा है कि आपने क्वेश्चन ध्यान से नहीं सुना है ना? मैंने बोला कि explain the N-type. You explain for the P-type. Understand? क्वेश्चन को पहले ध्यान से सुनना है. That is very important thing during the interview. Understand?
Okay. Okay,
now,
sir.
Okay.
Sir,
now move to the explain.
Okay, sir. So, sir, in P-type, N-type semiconductor, actually, there is no any charge. Externally, there is no any charge there. Actually, N-type semiconductor is created due to addition of pentavalent atom, and it has an extra electron. But that extra electron keeps on moving, and that is keeps on moving inside the semiconductor. But it's not give any charges to the semiconductor.
Why electron has the charge? Why it is not has charging?
Yes,
Electron has a negative charge, and in the N-type there are majority of the electron.
Yes,
then why
actually, you are right. You are right, according to that. But it is we have not ionized or we have not inserted the ionized pentavalent atom. We have just added or doped the pentavalent atom, which already has one extra electron. But according to the bond diagram, that extra electron keeps on revolving inside the semiconductor, through which we find the conduction in the semiconductor. It's not creating any extra charge.
Ayush, you are telling that this extra electron is bounded, not free. This you want to
until we do not give any external charge, some little amount of charge like 0.005 electron volt.
Let's take we have given the energy and we have proper ionization. Now tell me what will be the charge. अभी आपने बोला कि आयोनाइजेशन नहीं हुआ है, मैंने बोल दिया आयोनाइजेशन हो गया है. अब बोल रहा है अब क्या होगा? अब नेगेटिव चार्ज आएगा.
If there will ionization means a positive ionization or negative ionization. What you are saying? Okay, sir. If there will positive ionization means its electron has been taken out, means pentavalent electron is there, and then its electron is positive ionization for extra electron is taken out. Okay, so when it will be doped, there will be charge in the semiconductor, but it will not act as the it will not conduct in that case, sir, because it do not have the electron which will help in the conduction for the positive ionization. For the negative ionization, it will be ionized. It will be ionized and it will be considered as the heavily doped, I think. I'm not sure about that, but it can be considered as a heavily doped because one extra electron.
What is your conclusion? अभी तक आपने कंक्लूजन नहीं बताया. आपने पॉजिटिव बता दिया, नेगेटिव आयोनाइजेशन बता दिया, पर कंक्लूजन नहीं बताया जो मैंने क्वेश्चन पूछा. मैंने क्या बोला है? ए आयोनाइज हो गया है, तो अब कैसे ए न्यूट्रल है?
नो सर, अब न्यूट्रल नहीं है.
अब नहीं है मतलब इस पर नेगेटिव होगा चार्ज.
यस सर.
तो न्यूट्रल कब होता है? जब तक आयोनाइज नहीं होते तब तक न्यूट्रल रहता है. मतलब ऐसा होता है क्या?
यस यस, आयोनाइजेशन एनर्जी जब तक क्रॉस नहीं करेगा तब तक वो न्यूट्रल ही रहेगा.
मींस बिफोर द एनर्जी गैप, जो एनर्जी गैप की एनर्जी रिक्वायर्ड है ना, सपोज फॉर द सिलिकॉन 0.7, इतनी एनर्जी आपने नहीं दी तब तक के न्यूट्रल है, अदरवाइज इट बिकम द नेगेटिव चार्ज। दिस इज द थिंग, यही है आपका मतलब?
नो सर, आई एम टॉकिंग अबाउट द डोप्ड एटम, मींस अगर डोप्ड एटम नेगेटिवली चार्ज्ड है तो पूरा का पूरा जो इंट्रिंसिक एक्सट्रिंसिक सेमीकंडक्टर जो होगा वो नेगेटिवली चार्ज हो जाएगा। मैं सर ये कह रहा हूँ।
पर मैंने तो ये जैसा पढ़ा है अभी तक कि एन टाइप तो न्यूट्रल रहता है सभी केस में, चाहे आप उसे एनर्जी दें चाहे ना
जब
दें।
आयनाइज नहीं होगा तब।
नहीं, आयोनाइजेशन होने के बाद भी न्यूट्रल रहता है।
आयनाइजेशन होने के बाद भी सर।
कंसेप्ट, बेसिक कंसेप्ट आयुष, हाउ वी क्रिएट द एन टाइप, इसको आप ध्यान देंगे ना तो आपको इसका आंसर मिलेगा, बट एन टाइप न्यूट्रल ही रहता है। चले बाद में बात करते हैं इसके बारे में, ठीक है? चले कौन कौन से सब्जेक्ट आप पढ़ के जा रहे हैं फॉर द इंटरव्यू?
सर ईडीसी, एनालॉग एंड सम पार्ट ऑफ डिजिटल एंड नेटवर्क।
Okay. Some part of digital and network. Chale, let's take question from the digital
मैथमेटिक्स ऑल्सो।
electronics. What is the logic family? Why we study logic family?
Because sir, logic family makes the thing very easier to means in digital platform it will become very easier to what I can say, लॉजिक फैमिली सर बहुत आसान हो जाता है। मतलब कि हम
क्या
लोग जो भी काम करते हैं, जो भी कैलकुलेशंस या मैनिपुलेशंस करते हैं वो काफी इजीली
Ayush,
वे हो जाता
you are going for a interview in IISC, understand?
है।
So वहां पर कॉलेज इंटरव्यू नहीं है अपना, ठीक है? कि अपन
Yes.
ने जो भी है आया है, आप खुद ही सोचा, आप खुद ही अपने आंसर को सुने। व्हाट यू आर सेइंग, बाय यूजिंग अ लॉजिक फैमिली काम आसान हो जाता है, यही आप बोल रहे हो ना?
Yes, sir.
ठीक है, अब
That
आप
is.
बताएं, अब आपने मेरे से क्वेश्चन पूछा लॉजिक फैमिली क्या है, मैंने ये जवाब दिया कि लॉजिक फैमिली का यूज करके काम आसान हो जाता है, ठीक है? IISC बेंगलुरु में मैं इंटरव्यू दे रहा हूँ, दैट इज द, आई थिंक मुझे कहना चाहिए बिगेस्ट रिसर्च है अपने, जहाँ पे जितने इंस्टीट्यूशन है उसमें सबसे बड़ा रिसर्च वहां चल रहा है, और इक्वली मान लो ये और भी चल रहे होंगे। अब आप बताइए आंसर
Yes.
सही है? नहीं आ
No,
रहा है
sir.
तो सॉरी, नो प्रॉब्लम सर, आई
Okay, sir.
वांट टू
Okay, sir. Okay,
अंडरस्टैंड,
sir.
समझ रहे हैं क्या?
Okay, sir. Okay, sir. ये
इंपॉर्टेंट,
क्वेश्चन सर नहीं आ रहा मुझे उतना।
नहीं आ रहा कोई दिक्कत नहीं है, इट इज
Okay,
नॉट नेसेसरी यू शुड गिव द आंसर ऑफ ईच एंड एवरी क्वेश्चन, है ना?
okay,
और इट इज नॉट नेसेसरी कि उन बच्चों का ही सिलेक्शन होता है जिन्होंने सभी आंसर दिए, मैं आपको ये भी बता दूं, ठीक है ना?
okay, sir.
फ्रॉम माय एक्सपीरियंस, और मेरा खुद का जो इंटरव्यू का एक्सपीरियंस है जो मैं उसमें बैठा हूँ, कि आप उनको आना चाहिए, यू नो द कॉन्सेप्ट और यू कैन कनेक्ट वन कॉन्सेप्ट ऑफ वन थ्योरी टू अनदर थ्योरी, दैट इज इंपॉर्टेंट थिंग, है ना? यू
Okay,
कैन
sir.
लर्न न्यू थिंग, दैट इज द इंपॉर्टेंट। चले नेक्स्ट क्वेश्चन पे
Okay.
आते हैं। तो फर्स्ट
Yes.
ऑफ ऑल, कैन यू डिजाइन NAND gate by using of diode?
NAND gate by using of diode. Let me think 1 minute, sir. Then I will answer.
Yes, take your time, take your time.
Yes, sir. We can design NAND gate by using diode. You want me to design right now, sir?
क्या बता दें? अगर आपने कर लिया है, आपने डिजाइन कर लिया है क्या?
एक मिनट सर, एक मिनट।
NAND गेट को डायोड से बनाना बहुत ही आसान है। If you appear in gate, this is a very basic question for the gate. I think 2 and 3 times आ चुका है गेट, बहुत ही बेसिक क्वेश्चन बोला है मैं तो ये। चले, नो प्रॉब्लम। चंद्रा सर will continue the for technical and other interview. Sir.
Yes, sir. Yeah, Ayushman.
Yes, sir.
How are you?
Hello, sir.
So you said that you are.
Sir, your sound is not clear.
How is it clear? Hello.
No, sir. It is slightly shivering.
Okay. Just a minute.
Yes, sir.
Give me a minute. Now is it okay?
Yes, sir.
Okay, fine. So you said that you prepared some sort of network analysis also, right?
Yes, sir. Analog.
Okay, fine. So let me start with this network analysis part. Okay.
Okay, sir.
What is the time constant?
Excuse me, sir.
What is the time constant?
Time constant.
Yes.
The time constant for any circuit is actually the voltage or current reaches to 0.07% of the maximum value. That time is known as time constant.
0.07. It is.
Yes, sir.
Why is
0.70.
0.07 only?
Sir, I can't know, sir. I don't know about this.
What is the time constant of series RC network?
Series RC network.
Yes.
1 by RC, sir.
1 by RC. What are the units of time constant?
What are the unit of time
what are the
constant?
Units of
Yes,
time
sir.
constant. Units.
It's second, sir.
Can you prove that 1 by RC is giving a second? Can you prove that?
Okay, sir. 1 minute, sir. Yes, sir. I can prove. Actually, R is actually V by I, and Q is actually C by V. So if we let me show you. If I can do like this.
So my question is, you got 1 by RC as second.
Yes, sir.
You got it?
Yes, sir.
I don't think. Can you do again?
Okay, sir. Let me. So it's a 1 by second actually. RC is actually, sorry, sir. Time constant is actually RC and its unit is second, sir.
Okay. What is the time constant of parallel RC network?
Parallel RC network. It's also RC, sir.
Okay. How
1
can you
minute.
say?
1 minute, sir. 1 minute. Excuse me, sir. What you asked actually? Time constant of parallel.
Parallel RC also it is RC. What's your explanation for that?
1 minute, sir. 1 minute, sir. Okay, great. Yes, sir. It is RC actually. I'm getting. Time
Yes.
constant is
Fine. Okay. Let's move to the
okay, sir.
next question.
Okay, sir.
How to reduce time constant? What is the method of reducing time constant?
For RC network or
Yeah, for
RL
example,
network.
just RC only.
Okay, sir. If we want to reduce then we can add resistance in parallel.
Resistance in parallel to what?
To any RC network.
Okay. So resistance in parallel to which element you want to add?
In R means the resistance. If we reduce the resistance, then also the time constant RC will reduce.
So what? So why can't you choose the method of reducing capacitance?
Excuse me, sir. I can't listen actually. Method of?
Tau is equal to RC, right?
Yes, sir. Tau equals to RC.
For reducing time constant, we are going with the reduction in resistance, you are saying.
Yes, sir.
Why can't we reduce capacitance? First of all, is it possible to reduce capacitance?
Yeah, we can also reduce capacitance by adding resistance capacitance in series. Then also the resistance will decrease actually.
But can we go for that reduction in capacitance practically?
Practically, we have to add the resistance. We have to add the capacitance in that case. And practically capacitance can be added. I have not.
Fine. See,
Okay.
we all know that the capacitor does not allow sudden change in its voltage, right?
Yes, sir. Yes, sir.
Why it is not allowing sudden change in its voltage?
Because sir, actually it has a capacity of storing the charges, and it has capacity ability to store charge, sir. That's why it do not allow the
In
current.
what way that ability to store is not accepting sudden voltage?
Excuse me, sir. Can you repeat the question, sir?
Yeah, you are saying that it is storing
Yes, sir.
energy, right?
Yes, sir. It's storing the charge.
Yeah. In what
Voltage.
way that storage of charge is affecting not to allow sudden change of voltage across it? Very simply, क्या रिलेशन है ये स्टोरेज ऑफ चार्ज और वोल्टेज का करंट चेंज में, दोनों के बीच में क्या रिलेशन है?
C equals to QV actually. Sorry, Q equals to CV. So if we differentiate change in voltage, if you are saying Q equals to CV, then dq by dt equals to C dV by dt. That is I equals to C dV by dt. So if I changes, voltage doesn't change.
Yeah, fine. Let's go for the next question.
Okay, sir.
Can you design an RC network?
Yes, sir.
Which is having low charging time constant and high discharging time constant?
Low charging time constant and high discharging time constant. Okay, sir. One minute.
Yeah. Yeah.
Yes, sir. Circuit maybe like, I think maybe the resistance and
What is the charging time constant of that?
charging time constant is actually RC.
Okay. Discharging time constant.
Yes, sir. Discharging time
Discharging
constant.
time constant.
Discharging time constant will be RC by 2, sir.
How it is RC by 2?
When the circuit will completed, then RR will be parallel and it will decrease the total resistance value, that is R by 2.
In your circuit, RR both are in parallel.
Yes, sir.
How?
While this in the circuit, sir,
So from where you are looking that both are in parallel, from where you are calculating?
actually when we connect actually, and both will be in parallel.
First of all, you kept one switch there. When you are going to on it, when you are going to off it, switch.
Oh, excuse me.
You kept one switch in the circuit.
Yes, sir. Yes, sir.
When you are closing it, when you are opening it.
Yeah. Yes, sir. I am in my circuit. I am switching the circuit actually while charging, the opening the circuit, and while discharging, closing the circuit.
No, my
In that
question
case,
is with respect to time, you tell that it is equal to 0 or at some time. So that way it has to be like, it's not to be like when charging or discharging. No. My question is, when
yes,
at what point of time you are closing it, at what point of time you are opening it?
okay, sir. So at maximum, when the capacitor attains maximum value, voltage, at that time.
How do you know that? How do you know that capacitor attains maximum value? How do you know that?
So when the why after the after it attains the maximum voltage, actually the circuit gets short. No, so circuit gets open actually. In that case, the current will not flow down. In that case, we can find that capacitance is maximum charged.
But what is the parameter for that? What is the parameter you are using that capacitor is fully charged? See, if I am asking you, how can I know that my capacitor is fully charged? Are you putting voltmeter there?
Yeah. Yes, sir. We can put voltmeter there.
Is there a need of putting voltmeter?
We can put a.
In terms of time constant, can't we say? In terms of time constant, can't we say whether a capacitor is fully charged or not? How many time constants it takes for a RC circuit, in a RC circuit for capacitor to get fully charged?
4 time constant. Settling
4 or
time.
5?
4, sir. 4, sir.
At 4 time constants, what is the voltage across capacitor in terms of percentage?
In terms of percentance, approx 98%, sir, as I remember.
At 5 time constants, how much it is?
I didn't remember, sir, about 5 time constant.
Okay. Fine. Let me give you feedback, Mr. Ayushman. See,
yes,
I
sir.
strongly recommend you to brush up your concepts once again. The very first question I ask is, you're able to hear me?
Yes, sir. Yes, sir.
Very first question I asked was, what is time constant?
Yes, sir.
It is the time taken by the step response to reach 63.2% of its final value.
Yes, sir.
You was given something like 0.7. I don't know what is given.
Yes, sir. Right? Yes, sir. It is I0 by 0.7.
Yeah, fine. See, I strongly recommend you to go through the basics once again before you go for a final IISc interview.
Okay, sir.
Over to Vinay, sir.
Okay. Ayush, as
yes,
sir told, my feedback is also similar because you have to work on a basic concept. आपको basic चीजें पढ़नी है. ये क्वेश्चन जो मैंने पूछे हैं, ये भी मैंने कोई ज्यादा डेप्थ वाले पूछे ही नहीं थे. ना, सबसे पहले अपन किसी से क्वेश्चंस पूछते हैं. When we started the interview, तो हम पहले बेसिक्स पूछते हैं, है ना. Then we see कि बच्चे को कितना आता है. Then step by step हम उसमें डेप्थ में जाते हैं. Understand? And you are going for IISc. So my suggestion is that you have 2 days. I think your interview is 18th. 18 को आपको.
Yes, sir. Yes, sir.
थोड़ा सा अभी पढ़ना पड़ेगा. बेसिक बात है. ठीक है, जैसे मैंने बोला एन टाइप पे चार्ज न्यूट्रल क्यों होता है, वेरी बेसिक है। जब आप उसमें पेंटावेलेंट मिलाते हो तो एक एन टाइप निकलता है, इलेक्ट्रॉन निकलता है, बट जहां से इलेक्ट्रॉन वहां से निकला हुआ है, व्हेन इलेक्ट्रॉन इज गिवन दैट, वो क्या हो जाता है, इट विल बिकम द पॉजिटिव चार्ज एंड इलेक्ट्रॉन इज द नेगेटिव चार्ज, सो टोटली न्यूट्रल। अंडरस्टैंड, ये आप देखें, ठीक है, बहुत ही बेसिक बेसिक से क्वेश्चन है। और अनदर इंपॉर्टेंट फीडबैक इज आपको आंसर जो देना है टू द पॉइंट आंसर देना है ना। जैसे कि मुझे लग रहा है यू आर गिविंग द आंसर जो आपको आता है, आपने उस पर उसको घुमा रहे हो, बट वहां पर नहीं घुमाना है ना। आईआईएससी और कोई भी बड़े इंस्टीट्यूशन में आप इंटरव्यू देने जा रहे हो, उनको समझ में आ जाता है, एक ही क्वेश्चन उनको समझ में आ जाता है कि आप क्या बताना चाह रहे हो क्या है। तो बिल्कुल ऑनेस्टली आंसर देना है, जबरदस्ती आंसर नहीं देना है। इट इज वेरी 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 इंपॉर्टेंट। इफ यू डोंट नो, नो प्रॉब्लम, ऐसा कोई जरूरी नहीं है कि आपसे 10 क्वेश्चन पूछो 10 में से 10 का आंसर देना जरूरी है। ओके, सो माय फीडबैक इज दैट सिंपल, आप एक बार रिवाइज करें और चीजों को घुमाना नहीं है, टू द पॉइंट आंसर देना है, ठीक है। और प्रोजेक्ट का जो है, जो आपने शुरुआत में अपने इंट्रो में प्रोजेक्ट का डिस्क्रिप्शन दे दिया, नहीं केवल प्रोजेक्ट का टाइटल बता दें, दैट इज ओके। प्रोजेक्ट का डिस्क्रिप्शन, इंट्रोडक्शन, ठीक है। दैट्स ऑल फ्रॉम माय साइड। ओके,
ओके सर,
ठीक है, थैंक यू,
थैंक यू।
बेस्ट ऑफ लक।